So our final type of electron configuration is at the bottom of page 10, and these are called Lewis electron dot diagrams, or structures. Write down the blue stuff. These structures, or these diagrams, use dots to represent the valence electrons. We just talked about valence electrons in our valence configuration. If you haven't watched that part yet, please go fill that part in first. Because once we know how many valence electrons we have, and we can do that from that configuration, we can put that many dots around our element's symbol. And it is important that they go on this kind of invisible box around the element symbol. So if I have an element X, imagine this box around that element symbol in a nice square. And we're going to be putting our dots on the sides of that, not just in the corners, not lining everything, but kind of squarely in the middle of each side. And we're going to put one dot on each side of that element symbol before we start doubling up. And 2 dots is the most that we can put on any side. So a maximum of 8. Now, we're not going to actually draw this box, but you kind of need to visualize that around your element symbol as you're drawing the dots. Now, I'm going to write out the configuration for each of these elements so that you can understand where these come from, and we're going to derive how many valence electrons each one has. I promise you don't have to do this every single time, but you always can. The valence configuration will always tell us the number of valence electrons. So this is lithium's configuration, 1s2, 2s1. And the second energy level is our highest energy level. That's our valence electrons. And that 1 there tells us that it has 1 valence electron, which means lithium symbol gets 1 dot. It doesn't matter where that dot goes, as long as it's on one of those sides, or on top or on bottom, as long as it is along the sides of that lithium box, that invisible box. Beryllium is right next to it. It's at 1s2, 2s2. So the second energy level is still our highest energy level, except beryllium has 2 electrons in it, which means it gets 2 dots. It's important that they're on different sides. Doesn't matter whether it's top and bottom, left and right, left and top. Doesn't matter where they're at all. I've been doing this a while. I usually start at the top, work my way around clockwise. I'm not even 100% sure why, but it doesn't matter as long as they're on separate sides. Boron is right after beryllium. It goes all the way to 2p1. Don't make that think that you have 1 valence electron, because both of these terms are still in the second energy level. So we have 2 plus 1 is 3 total valence electrons. So boron gets 3 dots. Carbon is right after it, 1s2, 2s2, 2p2, which means it has 2 plus 2, 4 valence electrons. You might be starting to notice that as we go across, each square adds 1 electron to the atom, adds 1 number up in that top exponent area, which adds 1 valence electron. So you're probably not surprised to hear that nitrogen is going to have 5 valence electrons. Well, it ends at 2p3. So that 2 plus the 3 does give us 5. So we're going to put 5 dots around nitrogen, making sure 2 of them get doubled up on one side, but then the other 3 dots are on their own separate sides. I always put 1 on each before I double up, like with the arrows on our orbital notation. If you know there's going to be 5 dots and only 4 sides, you might know, okay, 2 of them are going to be sharing a side. 2 of them are going to be doubled up. That is a dangerous habit to get into, because once you start doubling, it's so easy to double up 2 sides to get 5. And that will not earn you full credit. You got the right number of dots, but they have to spread out if there is an open side available. Oxygen is going to get 6 dots. It goes all the way to 2p4. 2 plus 4 is 6 valence electrons, gives it 6 dots, which does mean that 2 sides are going to end up with 2 pairs. 2 of those sides are going to have some single lonely electrons on them. Fluorine goes all the way to 2p5, so 2 plus 5 is 7 valence electrons. So we're going to have 3 sides with pairs of dots, 1 side with a little lonely electron. And then you guessed it, neon is at 1s2, 2s2, 2p6, which means 2 plus 6 is 8 valence electrons. So all 4 sides have our doubled up dots. Now, I want to mention that argon, right underneath neon, has a very similar configuration. It is a little bit longer, but it ends at 3p6. So keep in mind, the third energy level in argon is its valence level. That's where its valence electrons are. But if we look at those numbers, the 2 plus the 6 is still there. So argon still has 8 valence electrons. So our number of valence electrons is the same in each column of the periodic table. We don't have to write out the full configuration and count up those numbers just to find the number of valence electrons. If it's not asking for a configuration, we can just use the periodic table like a guide. So I am going to ask you to draw out these 3 Lewis dot diagrams. It is important that you use their symbols. It's a silly point to lose. It would only be 1 point, but you can't just put dots around the names. That's not the way that we do Lewis dot diagrams. It has to be around the symbols. But let's go look at our periodic table at some of these patterns so we don't have to write out all those configurations to figure out how many dots to draw. So we saw that lithium has 1 valence electron. In fact, all of the elements in that first column have 1 valence electron. And you can probably see at the top of that column, it's labeled as column 1, so that 1 can kind of remind you, 1 valence electron. Same for column 2. They've got 2's above the column, 2 valence electrons for every element in that column. Now, our D block elements are a little weird. Technically, they still have 2. Everything has 2. At least that's the normal rule. Those D block elements don't always follow that rule until we get to boron's column. And boron, as we saw, has 3 valence electrons. Not 13, but 3. So if you focus on these A labels underneath the column numbers, because there are 10 columns of D's there, those A labels are kind of the main group elements, not with the transition metals, that the D block elements that don't follow the rules very much. The A labels will tell you how many valence electrons they have there. So if we're looking at our calcium and selenium and krypton, all we have to do is look at the numbers at the top of each of those columns. That tells us how many dots to put around those symbols. So that should be pretty quick and easy for you to finish up. And then there are a couple of practice problems later on that use Lewis dot diagrams. They're only on pages 13 and 14. We're done with 11 and 12 by now, hopefully. So it's really mostly page 14. I give you some diagrams for you to find the element, and I ask you to draw some diagrams on 17. Page 13, number 12, might not look like Lewis dot diagram problems, but this is the best place to figure out how many unpaired electrons are in each of these atoms below. If we draw nitrogen's Lewis dot diagram again, I know we just drew it, but it had 5 dots. 3 of those dots are unpaired. 3 of those dots are on a side without a buddy, which means that nitrogen has 3 unpaired electrons. So that is definitely the simplest way to be able to find our unpaired electrons. You can use the orbital notation. Sometimes that gives you some different answers, though. So don't worry too much about orbital notation for these. I'd really recommend you use the Lewis dot diagram. And remember, for nickel, if I wrote out that configuration real quick, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Its valence electrons, the thing telling us how many dots we'd have, are the highest energy level of electrons, 4s2, which means it has 2 valence electrons. So you'll put 2 dots around nickel, and that will help you figure out how many of your electrons are unpaired. So that should finish out the practice on pages 11 through 14. If you don't know which ones go with which, you can ask me in class, but most of them are pretty obviously labeled. But some of these, like 12, 13, and 14, you don't necessarily get told to write a configuration specifically, but they will always help you find that if you start with the configuration.